40,000 years ago, somewhere in what will one day become southern France, a figure stands motionless at the edge of a frozen tree line. The wind is coming from the northeast. He knows this. He has always known this. He tilts his head slightly, nostrils flaring, reading the air the way you might read a sentence, quickly, automatically, without thinking about the individual letters. The cold bites at the exposed skin around his eyes. Everything else is wrapped in the thick, reddish-brown hide of an aurochs he helped kill 3 weeks ago. He is not tall. He stands roughly 1.6 meters from the frozen ground to the crown of his heavy skull. But what strikes you, if you could somehow stand beside him in that tree line and look at him properly, is not his height. It is his width. His shoulders are broader than those of almost any modern human athlete. His chest is a barrel, deep and round, built to process oxygen in thin, cold air. His arms hang slightly forward, and the muscles of his forearms are so developed that the bones underneath them have been permanently reshaped by decades of force. The femur in his right leg carries a stress fracture, healed over years ago, that tells a story of enormous repeated impact. His hands, thick-fingered, scarred, extraordinary, rest at his sides. His name, of course, is not something we can know, but his face. We can reconstruct that face with remarkable precision now, thanks to decades of research, ancient DNA analysis, and forensic facial reconstruction. A broad, low forehead, a projecting midface, a nose wider and larger than any modern human nose, engineered not for aesthetics, but for warming and humidifying Arctic air before it reaches the lungs. A chin that recedes slightly. Eyes set beneath a heavy brow ridge, deep set and dark, watching the open ground beyond the trees with a patience that modern humans find almost uncomfortable to imagine. He has been standing here for over an hour. He is not bored. He does not fidget. The concept of wasted time does not exist in the architecture of this particular morning. There is only the wind, the smell on the wind, and what the smell means. And what it means is, they are close. This is not a story about a primitive creature stumbling through a hostile world. This is not the Neanderthal of old textbooks, the hunched, vacant-eyed brute dragging a club through the mud of popular imagination. That version of Neanderthal has been dismantled piece by piece over the last 3 decades by some of the most extraordinary scientific detective work in the history of human knowledge. What has replaced it is something far more astonishing, far more complicated, and in many ways, far more unsettling to our sense of human uniqueness. This is the story of a being who buried his dead with flowers, or possibly did. The evidence is still debated. A being who made jewelry from eagle talons 65,000 years ago in what is now Croatia, predating the arrival of modern humans in Europe by at least 20,000 years. A being who mixed pigments, who chose specific colors, who applied ochre and manganese dioxide to surfaces in patterns that at least some researchers believe constitute a form of symbolic expression. A being whose genome lives right now in the DNA of almost every non-African person on Earth. Between 1% and 4% of your genetic code, if you have European or Asian ancestry, was written by Neanderthals. A being who, on this particular morning, is about to participate in one of the most dangerous, physically demanding, and strategically complex activities that any land predator on this planet has ever attempted. He is about to help kill a woolly mammoth. Not with bare hands. Let us be clear about that immediately, because clarity is what separates science from mythology. And this story deserves science. He has weapons. They are not primitive. They are not crude. They are the product of a manufacturing tradition that stretches back hundreds of thousands of years, refined through generations of knowledge passed from individual to individual, in a species whose brain, pound for pound, was larger than yours. But the weapons alone would not be enough. They never are. What makes this hunt possible, what has always made this hunt possible, is something that cannot be held in the hand or found in the archaeological record with any single clean piece of evidence. It is something that lives in the space between individuals, in the glances exchanged at the tree line, in the positions taken up without spoken command, in the shared understanding of what comes next. To understand that, we need to understand him. Not as a symbol, not as a cautionary tale about extinction, not as a footnote in the story of our own species' rise. We need to understand him on his own terms, in his own world, on his own morning. So let us go back. Let us go back 40,000 years, to the Châtel-Perronian horizon, to the edge of the last glacial maximum, to a Europe that is colder and drier and more open than anything that exists today. Let us stand in that tree line with him, in the gray pre-dawn light, and follow one day from its beginning to its end. Because in that one day, we will find answers to questions that scientists have spent their careers trying to resolve. We will find evidence that overturns assumptions. We will find a creature that is neither human nor animal in the way those words are usually deployed, but something richer and stranger and more specific than either. And we will find, at the center of it all, a hunt. Methodical, brutal, intimate, and conducted with a level of coordinated intelligence that, for a very long time, we refused to believe was possible. The figure at the tree line exhales slowly. A small cloud of vapor dissolves into the cold air. He has seen something move far out across the open ground. He does not run. He does not shout. He simply shifts his weight almost imperceptibly, and somewhere in the trees behind him, two other figures register the movement and go completely still. The hunt has begun. Before we follow him out of that tree line, we need to stop. We need to stop and look at what is actually inside that heavy skull. Because for most of the 20th century, scientists made an assumption about Neanderthals that shaped everything. Every reconstruction, every museum exhibit, every theory about why they disappeared. The assumption was simple, and it was wrong. The assumption was that a different shaped brain meant a lesser brain. It seemed logical at the time. Neanderthal skulls are visually distinct from modern human skulls in ways that are immediately obvious even to an untrained eye. The brain case is long and low rather than tall and rounded. The back of the skull has a characteristic protrusion called an occipital bun. The frontal lobes, the region we associate with abstract reasoning, planning, and language, appear somewhat smaller in relative terms than in our own species. For decades, this architectural difference was interpreted as cognitive poverty, as limitation, as the neurological explanation for what was assumed to be a simpler, more reactive, less imaginative way of engaging with the world. There was just one problem with this interpretation. The total brain volume of Neanderthals was, on average, slightly larger than our own. Not smaller, larger. The average Neanderthal brain volume measured from fossil skulls comes in at roughly 1,600 cubic centimeters. The average for modern Homo sapiens is approximately 1,350 cubic centimeters. This is not a marginal difference. It is a difference that, if the numbers were reversed, if we were the species with the smaller brain, would have been cited endlessly as evidence of our cognitive inferiority. Now, brain volume alone does not determine intelligence. This much is understood. The organization of neural tissue, the density of connections, the specific development of particular regions, these matter enormously. And there are genuine structural differences between Neanderthal and modern human brains that researchers have spent years trying to interpret. A 2018 study, published in Scientific Reports, used virtual endocasts, three-dimensional models of the interior of fossil skulls, combined with computational modeling to suggest that modern humans have a more globular or rounded brain shape that correlates with expanded parietal and cerebellar regions. These regions are associated with spatial processing, attention, working memory, and certain aspects of social cognition. What this means in practice remains genuinely contested. What we can say with confidence, based on the archaeological record, is this: Neanderthal behavior was not simple. Consider the site of Bruniquel Cave in southwestern France. In 2016, a team, led by Jacques Jobert of the University of Bordeaux, published findings in Nature that stopped the scientific community in its tracks. Deep inside the cave, 176 meters from the entrance, far beyond any natural light, researchers found structures. Deliberate structures, built from broken stalagmites, arranged in rings and lines. Some of the stalagmites showed evidence of fire. The structures were not created by accident or by geological process. They were built. The uranium-thorium dating of the calcite coating on these structures placed their construction at approximately 176,000 years ago. 176,000 years ago. At that date, anatomically modern Homo sapiens had not yet left Africa. The only hominin in Europe capable of building those structures was Neanderthal. And what those structures represent: a deliberate journey deep into darkness, the construction of something that served no obvious immediate survival function, the use of fire underground, suggests a level of planning, intentionality, and perhaps symbolic behavior that was, until that discovery, considered impossible for Neanderthals. Or consider the eagle talon jewelry from Krapina in Croatia, studied by David Frere of the University of Kansas and published in 2015. 8 white-tailed eagle talons dating to approximately 130,000 years ago, bearing cut marks and polishing consistent with having been strung together as a necklace or bracelet. The cut marks are not random. They are precise, deliberate, placed at specific points on the talons in a way that makes sense only if the maker understood what they were creating. An object of adornment, of display, of meaning beyond pure utility. The Neanderthal who made that jewelry was not reacting to the world. He or she was decorating it. Back in the tree line, the figure we have been watching carries in his skull a brain shaped by 700,000 years of Neanderthal evolution in Europe and Western Asia. His lineage split from the lineage leading to modern humans somewhere between 300 and 800,000 years ago, depending on which genetic analysis you follow. The range reflects genuine ongoing scientific debate. His ancestors survived ice ages, adapted to climates ranging from Mediterranean warmth to subarctic cold, competed with cave lions and cave hyenas and giant deer, and produced along the way a cognitive architecture that was neither identical to ours nor inferior to it. It was different, specialized, built for a particular kind of world. And one of the things it was extraordinarily good at was reading the physical environment with a precision that modern humans struggle to replicate, even with training. A study published in the Journal of Human Evolution in 2021 analyzed the semicircular canals of Neanderthal inner ears, the structures responsible for balance and spatial orientation, and found configurations suggesting a movement pattern distinct from modern humans. Broader, lower, more stable. Built for terrain navigation under load. Built for the kind of movement that happens when you are carrying a heavy spear across broken ground and cannot afford to fall. His body and his brain are not separate systems. They are a single integrated solution to the problem of survival in Pleistocene Europe. He knows this valley. He has moved through it in winter and in the brief, fierce summers. He knows where the river bends and creates soft ground that holds prints for days. He knows which slopes face south and lose their snow first, drawing herbivores out of the dense forest when the cold is worst. He knows the smell of a mammoth, a deep, musty, animal smell that carries on cold air for hundreds of meters. And he knows the difference between a smell that is old and a smell that is fresh. The smell this morning is fresh. There are 3 of them in the hunting party. This is worth noting because for a long time, the assumption was that Neanderthal hunting was a solitary or loosely cooperative affair. Individuals or pairs opportunistically pursuing prey rather than engaging in the coordinated group hunts that characterize modern human forager societies. This assumption has been systematically dismantled by taphonomic analysis, the study of how animal bones end up where they are found, at sites across Europe. At the site of La Côte des Saints-Brelades on the island of Jersey, researchers found the stacked bones of at least 5 woolly mammoths and 3 woolly rhinoceroses at the base of a granite headland. The pattern of the bones and their relationship to the landscape strongly suggests that Neanderthals drove these animals over the cliff edge deliberately, a hunting strategy requiring multiple individuals working in coordination, planning routes of approach, and understanding how prey animals respond to perceived threat. The site dates to approximately 240,000 years ago. At Neumarkt Nord in Germany, the analysis of hundreds of horse bones at a lakeshore site suggests systematic, repeated, organized hunting over many seasons. At Abric-Romani in Spain, the spatial distribution of butchery marks on bones across multiple hearth sites suggests not just individual hunters, but structured division of carcasses among group members, which implies, in turn, a social architecture of sharing, obligation, and perhaps hierarchy. 3 hunters, then, at the tree line. The figure we have been following, let us call him what he almost certainly was to his group, which is to say, someone known by a specific sound that meant specifically him, is not the youngest. His healed injuries tell a different story. The stress fracture in his femur, a partially healed rib on his left side that knitted crookedly after a trauma we can only imagine, a tooth, the upper left second molar, worn down on one side in a pattern consistent with using his mouth as a third hand, gripping hides or sinew while working them with stone tools, a behavior documented in Neanderthal dental wear patterns and described in research by Amanda Henry at the Max Planck Institute. He is experienced. He has done this before. He knows what is about to be asked of his body, and his body has the record of that knowledge written into its bones. Behind him, slightly to the left, stands a younger individual, leaner, faster, with the kind of explosive lateral movement that experience has not yet traded away for endurance. And to the right, barely visible against the dark bark of a pine, a third figure, broader even than the first, carrying a weapon that we will examine very closely in the next part of this story. The wind shifts, just slightly, just enough. The 3 figures freeze simultaneously, without signal, without sound. Across the open ground, something large and dark and slow moves against the pale gray of the frozen landscape. Let us talk about the spear. Not because it is the most interesting thing about this hunting party, but because for decades, the question of whether Neanderthals even had proper throwing spears was used as a cornerstone argument for their cognitive inferiority, and because the answer to that question, when it finally came, arrived from a direction nobody expected and changed the entire conversation. The old model was straightforward. Neanderthals, according to this view, were thrust hunters. They got close, very close, dangerously close. They used their enormous upper body strength to drive heavy spears into prey at short range, essentially using the weapon as an extension of their arms rather than as a projectile. Evidence for this model came from biomechanical analysis of Neanderthal shoulder joints, which appeared to show a configuration less suited to overhead throwing than the modern human shoulder. It also came from the injuries, because the Neanderthal fossil record is full of injuries, healed fractures of the kind associated with violent, high-impact, close-range encounters with large animals. A study by Thomas Berger and Eric Trinkus, published in the Journal of Archaeological Science, found that the pattern of traumatic injuries in Neanderthal skeletons closely resembles the injury profile of modern rodeo riders, people whose profession involves repeated, intimate, high-force contact with large, unpredictable animals. This was interpreted as confirmation. They got close, they got hurt, they survived, they went back and got close again. It is a compelling image. It is also incomplete. In 2018, a team led by Annemiek Milks at University College London published a study in Scientific Reports that should have received far more attention outside specialist circles than it did. Milks and her colleagues constructed replicas of the Schöningen spears, a set of wooden throwing spears discovered in a lignite mine in Lower Saxony, Germany, dating to approximately 300,000 years ago and attributed to Neanderthal predecessors, possibly Homo heidelbergensis. 8 spears, preserved in extraordinary condition in waterlogged sediment, ranging from 1.8 to 2.5 meters in length, made from spruce wood, weighted toward the front in exactly the same way as modern athletic javelins. The team gave these replica spears to trained javelin athletes and asked them to throw them at a target. The results were unambiguous. The spears flew accurately at distances of up to 15 meters. They hit with sufficient force to penetrate the hide and muscle of large prey animals. They were not thrusting weapons. They were designed, from the weighting to the tip, to be thrown. And the individuals who made them understood aerodynamics, not as an abstract principle, but as applied knowledge embedded in the craft of making the weapon itself. 300,000 years ago. Now, the Schöningen spears predate the Neanderthals we are following by a considerable margin, but the Neanderthal technological tradition did not regress. It developed. What our figure at the tree line carries is not a Schöningen spear. His weapon belongs to what archaeologists call the Mousterian tradition, named after the site of Les Moustiers in the Dordogne region of France, where the characteristic stone tools of Neanderthal technology were first systematically described in the late 19th century. The spear he carries consists of a wooden shaft, ash or birch most likely, selected for straightness and flexibility, approximately 2 meters long. At its tip, hafted with birch tar and bound with sinew, is a stone point, not a crude chip of flint, a Levallois point. The Levallois technique is one of the most technically demanding stone knapping methods in the entire prehistoric record. To produce a Levallois flake, a knapper must first shape a stone core into a specific three-dimensional form, a tortoiseshell shape, through a carefully controlled sequence of preparatory flakes. Only then is the final flake struck, detaching a piece of predetermined size, shape, and thickness from the prepared core. The entire process requires the ability to hold a three-dimensional mental model of the finished product in mind while working through the preparatory stages, maintaining spatial planning across a sequence of perhaps 30 or 40 individual strikes, each of which must be precisely placed to set up the next. Experiments by researchers, including Jacques Pellegrin at the French National Center for Scientific Research, have demonstrated that learning to produce consistent, high-quality Levallois flakes takes a modern human napper approximately 100 hours of dedicated practice. Some estimates suggest considerably more. This is not accidental. This is not reactive. This is learned, transmitted, accumulated knowledge, technology in the fullest sense of the word. The point on the spear our figure carries is sharp enough to shave with. The edge, examined under a scanning electron microscope, as researchers at the University of Tübingen have done with comparable Mousterian points, would reveal a cutting geometry more precise than many modern steel knives. The hafting, the attachment of stone point to wooden shaft, is accomplished with birch tar, a substance that does not occur naturally in that form and must be manufactured. Making birch tar requires heating birch bark in a low-oxygen environment to a controlled temperature, which means either a specific fire management technique or a sealed container of some kind. A 2019 study by Schmidt and colleagues, published in the Proceedings of the National Academy of Sciences, experimentally demonstrated multiple methods by which Neanderthals could have produced birch tar, some of which require nothing more sophisticated than an ember and a piece of bark, but all of which require understanding of process, of cause and effect, of controlled transformation of raw materials. Neanderthals were manufacturing chemicals, intentionally, repeatedly. The third member of the hunting party, the broad-shouldered figure to the right, carries something slightly different. His weapon has a heavier shaft and the point is larger, a bifacial point worked on both faces that would create a wider wound channel. It is a weapon designed for penetration rather than long-range accuracy. It is a close-range weapon, and the fact that he is carrying it rather than the lighter throwing spear tells us something about the role this individual is expected to play and what is about to happen. They have a plan. The weapons in their hands are not interchangeable. They reflect a division of function, which implies, in turn, a prior conversation, or at minimum, a shared understanding built over enough previous hunts that the roles have become established. Who throws from distance? Who drives the animal? Who closes in when the time comes? How did they communicate this plan? This question sits at the center of one of the most heated debates in all of paleoanthropology, the question of Neanderthal language. The hyoid bone, a small U-shaped bone in the throat that anchors the muscles of the tongue and is essential to the production of complex speech, was recovered from a Neanderthal skeleton at Kibara Cave in Israel in 1989. It was anatomically indistinguishable from the hyoid of a modern human. The FOXP2 gene, associated in modern humans with the fine motor control required for speech production, was recovered from Neanderthal DNA extracted from specimens at El Cedrón Cave in Spain in research published in 2007. Their version of FOXP2 contained the same derived variants as the modern human version, variants not found in chimpanzees. The vocal anatomy was there. The genetic basis for speech motor control was there. What this means for the actual complexity of Neanderthal communication remains genuinely uncertain. Possession of the hardware does not guarantee operation of the software. But the position, increasingly common among researchers who study this question seriously, is that the burden of proof has shifted. It is no longer the case that we must prove Neanderthals could speak. It is becoming the case that we must explain why, given the anatomy, the genetics, the social complexity, and the technological sophistication of what they were doing, they would not have used language. Out in the open ground beyond the tree line, the mammoth moves slowly against the gray morning sky. It is not alone. There are two of them. A large adult, a female based on tusk curvature, and a younger individual, perhaps 4 or 5 years old, moving close to her left flank. The adult's shoulder height is approximately 3 meters. Her estimated weight is somewhere between 4 and 6 tons. Her tusks curve outward and upward in the characteristic arc of Mammoths primigenius, the woolly mammoth. Instruments evolved primarily for scraping snow from vegetation, but capable, when the animal is threatened, of delivering a blow with force sufficient to shatter bone. The hunting party knows this. Every healed fracture in the fossil record knows this. The younger individual is the reason everything is about to become considerably more dangerous than it might otherwise have been. Because the younger individual means the adult will not simply flee. And the figure at the tree line, reading the shapes across the frozen ground, has already understood this. The slight adjustment of his weight, the almost imperceptible redirection of his gaze toward the second figure in the trees, the pause, and then a decision. The decision takes less than 3 seconds, and yet inside those 3 seconds is compressed everything that separates a successful hunt from a catastrophic failure. Everything that separates a group that eats tonight from a group that does not. Everything that separates the living from the dead. He chooses the younger animal, not because it is easier. In some ways, as we will see, it is harder. But because the adult female, if separated from her calf, will charge repeatedly, without the calculating self-preservation instinct that governs the behavior of most prey animals. A mammoth cow defending her young is not fleeing prey. She is an incoming projectile weighing 5 tons, and there is no version of that scenario that ends well for a creature made of bone and muscle and birch tar, no matter how good his spear is. But if they take the younger animal, if they can cut it away from the adult, drive a wedge between them, create enough confusion and fear that the cow retreats rather than engages, then the dynamic changes entirely. This is not instinct. This is not stimulus and response. This is game theory, applied in real time by a brain that has run this calculation before, in this landscape, in this cold, with these specific animals and these specific companions. Let us be precise about the landscape, because the landscape is not backdrop. The landscape is a weapon. 40,000 years ago, in what is now the Périgord region of southwestern France, the terrain looked nothing like the gentle forested hills of the modern Dordogne. The last glacial maximum had not yet reached its peak. That would come approximately 10,000 years later, but the climate was already dramatically colder and drier than today. The forest cover was sparse and fragmented. Between patches of pine and birch woodland lay open stretches of grassland and steppe, wind-scoured and flat, dusted with snow that had not melted since October. The rivers ran lower and faster than their modern descendants. The valley walls were steeper, carved by ice and meltwater into configurations that created natural funnels, corridors, and dead ends in the landscape. Neanderthals knew these features, not abstractly, not from maps or described knowledge, from repeated physical experience, from having moved through this specific terrain across seasons and years, from having watched prey animals move through it, from having learned, through direct observation and possibly through communication with others, where the ground goes soft, where the valley narrows, where a retreating animal has nowhere left to go. The site of La Côte des Saint-Prelades, which we mentioned earlier, is the most dramatic surviving example of this landscape knowledge in action. A granite headland on the coast of Jersey with a ravine running along one side. The bones of mammoths and rhinoceroses at the base of the ravine, stacked in a pattern that geological analysis shows cannot be explained by natural accumulation. The animals were driven there, deliberately, by hunters who understood the topography well enough to use it as infrastructure, to turn the shape of the ground itself into a trap. What our figure at the tree line has identified this morning is a smaller version of the same principle. 40 meters to the east, where the open ground begins to slope downward toward the frozen river, there is a place where the bank has collapsed, leaving a drop of approximately 2 meters into the riverbed. It is concealed from the animal's current position by a low ridge. It is not an impassable obstacle for a healthy adult mammoth. They are extraordinary terrain navigators, capable of moving through environments that defeat most other large animals. But for a juvenile, panicked, separated from its mother, moving fast in the wrong direction, that drop represents several crucial seconds of confusion. Several crucial seconds in which a hunter on foot can close a distance that would otherwise be impossible to close. He has not explained this to his companions. He did not need to. They have been here before. They know this valley the way you know the layout of your home in complete darkness. Not through active recall, but through the body itself, through the feet and the hands and the accumulated weight of repeated experience. The three figures separate without a word. The youngest moves left, wide, making a long arc through the trees that will bring him around to the far side of the animals, the side away from the river. He moves fast but low, using the tree line as cover for as long as possible, his footfalls almost silent on the frozen ground. The soft boots he wears, constructed from mammoth hide, we know from impressions left in cave sediments and from the wear patterns on Neanderthal foot bones, are not accidents of warmth. They are tools of silence. The broad-shouldered figure to the right moves toward the edge of the trees, positioning himself at an angle that will, when the time comes, appear to the animals as a threat from the south. Not a direct approach, an angle. Because a direct approach tells a prey animal exactly where the danger is and exactly which direction to run. An angle creates ambiguity, and ambiguity in a prey animal's decision-making costs time. The figure at the tree line, the experienced one, the one with the healed fractures and the worn tooth, does not move yet. He waits. This patience is itself a technology. It is a cognitive achievement. The human capacity for patient waiting in pursuit of a delayed reward is not a given. It is something that must be developed, maintained, and in some circumstances, actively suppressed when the body's alarm systems are screaming at you to act. Research on stress hormones in modern hunter-gatherer populations during hunts shows cortisol levels consistent with extreme physiological arousal. The body wants to move, wants to react, wants to resolve the tension. Holding that arousal in check, maintaining stillness while the plan unfolds around you, is work. Real work, performed by the prefrontal cortex against the insistence of the older, faster, louder parts of the brain. He holds it in check. 2 minutes pass, perhaps 3. And then, from the far side of the open ground, a sound. Not loud, not dramatic, just a branch, snapped with exactly enough force to carry across the frozen air to the ears of two animals whose hearing is tuned to frequencies of threat. The juvenile mammoth raises its head. The adult raises hers a half-second later, turning toward the sound, tusks sweeping in a slow arc as her head moves. She vocalizes, a low, resonant rumble below the range of comfortable human hearing that travels through the ground as much as through the air. Infrasound, a frequency used by elephants and their relatives for long-range communication, and almost certainly used by woolly mammoths in the same way. The research of Katie Payne at Cornell University on elephant infrasound, published from the 1980s onward, demonstrated that modern elephants maintain social contact and coordinate movement across distances of several kilometers using calls that humans standing nearby cannot consciously hear. The juvenile responds to its mother's rumble. It moves toward her. This is the wrong direction. And then, from the south, the broad-shouldered figure steps out of the tree line. He does not run. He does not shout. He simply appears at the edge of the animal's vision, at an angle, large and dark against the pale ground, and the effect is immediate. The adult wheels, not away from him, toward him, in that first explosive moment of threat assessment, and in wheeling, she moves away from the juvenile by 4 meters. 4 meters. It is enough. The youngest member of the hunting party breaks from cover on the far side, moving fast now, no longer concerned with silence, arms wide, driving directly toward the juvenile from the north. And the juvenile does what panicked young animals do when separated from their mothers by confusing threats from multiple directions. It runs. It runs in the only direction that appears open. It runs south and east, toward the low ridge, toward the collapsed riverbank, toward the place they chose for it. The experienced figure leaves the tree line at a dead sprint. He is not fast, not by the standards of a modern human sprinter. Biomechanical modeling of Neanderthal locomotion, based on skeletal proportions and muscle attachment sites, suggests a running gait that was powerful and efficient over broken terrain, but somewhat slower at top speed than modern Homo sapiens. The shorter lower leg segment, which conserves heat in cold climates by reducing surface area, also reduces stride length. But he does not need to be fast. He needs to be fast enough for long enough to close the angle. He is breathing hard within 30 seconds. The cold air burns. He has not eaten since yesterday afternoon, a detail we will return to, and his blood sugar is not where it would be in an ideal world. But the body has reserves. The Neanderthal physique, with its enormous muscle mass and broad thorax, was a system designed for exactly this kind of short, explosive, high-demand output. Research on Neanderthal metabolic requirements, published by Bendor and colleagues in 2011 in the American Journal of Physical Anthropology, estimated that a Neanderthal male of average size would have required between 4,000 and 5,000 calories per day during periods of high physical activity, roughly double the modern human requirement. They were biological engines, and right now, that engine is running. The juvenile mammoth, roughly 1.8 meters at the shoulder and weighing perhaps 600 kilograms, reaches the ridge. It does not slow down. It goes over the edge. The drop into the riverbed sends it to its knees, not down, not fallen, but stumbling, lurching, all 4 legs scrabbling at the frozen gravel of the riverbed, momentum carrying it forward in a controlled fall that takes 3 seconds to resolve. 3 seconds. He is at the top of the bank when the animal hits the riverbed. He does not stop to assess. He goes over the edge without pausing, lands on both feet, absorbs the impact through his legs in the way that decades of this kind of terrain have made automatic, and he is moving again before the juvenile has fully regained its footing. The spear comes back in his right hand. There is a precise location, known to anyone who has hunted large animals with a thrusting or throwing weapon, just behind the shoulder blade on the left side, where the shaft of a spear can pass between the ribs and reach the lung. Hunters of every culture on every continent who have used spears against large prey have discovered this location independently because it is written into the anatomy of large mammals and into the physics of the weapon. He knows this location. The juvenile turns its head toward him at the last moment, one dark eye enormous and close, and he drives the spear home. The Levallois point, sharp enough to shave with, hits the fourth rib, deflects, and slides between the fourth and fifth. The birch tar hafting holds. The shaft bends but does not break. He leans into it with the full weight of his body, 100 kilograms of dense Neanderthal muscle and bone behind a sharpened stone point, and feels the resistance change as the point enters the chest cavity. The juvenile screams. It is a sound that carries across the frozen valley and reaches, we can be almost certain, the ears of the adult on the ridge above. The infrasound component of that call drops through the ground like a stone through water. The adult's response is immediate and absolute. She charges the ridge, tusks forward, and the broad-shouldered figure who has been driving her from the south now turns and runs, because there are moments in a hunt where courage and suicidal stupidity become the same thing. And this is one of them. In the riverbed, the experienced hunter keeps his weight on the spear. The juvenile pulls forward. He goes with it. His feet drag on the frozen gravel. He does not let go. Behind him, now dropping into the riverbed from the bank, the youngest member of the party has a second spear, shorter, heavier, the one designed for close work, and he drives it in from the animal's right side with both hands, using body weight exactly as the older hunter is doing, and together they hold the animal as it staggers and turns and tries to find a direction that does not contain pain. It takes 4 minutes. 4 minutes that are a lifetime in close proximity to 600 kilograms of panicked animal. The juvenile mammoth goes down on its front knees first, then its hindquarters, and then it lies on its side in the gravel of the frozen riverbed, flanks heaving, breath coming in long, visible plumes in the cold air. The two hunters step back. Both of them are breathing hard. The younger one has a gash on his left forearm where a tusk clipped him, a tusk not much larger than a grown man's hand at this age, but moving with enough force to open skin to the bone. He does not look at it yet. He is looking at the animal. Above them, on the ridge, the broad-shouldered figure appears, breathing hard, checking the valley in both directions. He holds up one hand. The adult is gone. She ran north along the river, which is what prey animals do when the calf's distress calls stop. They flee, because the silence means the threat has been resolved, and what remains is only danger. The experienced hunter looks at the animal at his feet. He looks at his companions, and then he does something that no predator on this planet does. He kneels beside the animal and waits for it to finish dying, without looking away. We cannot know what was in his mind in that moment. We should be honest about that. The temptation to project modern human emotional experience onto a 40,000-year-old Neanderthal is one that serious researchers resist carefully, because projection is not science. But we can note as a factual matter that the archaeological record contains evidence of Neanderthal behavior around death, animal and otherwise, that does not fit purely within a framework of resource extraction. Ritual treatment of animal bones at certain sites, the arrangement of bear skulls at sites including Drachenloch in Switzerland, once interpreted as evidence of a bear cult, and now understood to be more ambiguous, but still not easily explained as pure accident. The burial of Neanderthal dead, at sites including Shanidar in Iraq, La Chapelle-aux-Saints in France, and Kibara in Israel, in positions and contexts that suggest at minimum deliberate placement, and possibly something more. What more we cannot say with certainty, but kneeling in a frozen riverbed beside a dying animal, in the gray morning light of a world that no longer exists, he is not nothing. He is not a reflex. He is not a stimulus and its response. He is something we do not yet have the right word for. And what he is about to do next, what the next hours of this day will reveal, will take us even deeper into the question of what, exactly, was lost when the last Neanderthal drew his last breath. The cold is getting worse. It does this in the early morning in this part of the world, in this period. The temperature drops sharply in the hour after dawn before the pale winter sun climbs high enough to begin its slow, inadequate work on the frozen air. The breath of the three hunters rises in thick clouds above the riverbed. The blood from the juvenile mammoth steams where it meets the gravel. They have perhaps 4 hours before the cold becomes a serious problem, perhaps less if the wind picks up. They get to work. What happens next is not butchery in the crude, hacking sense that the word implies. What happens next is surgery. It is engineering. It is the application of a detailed, three-dimensional knowledge of animal anatomy that has been accumulated over hundreds of thousands of years and transmitted across generations with a fidelity that the archaeological record only partially captures. The stone tools come out. The experienced hunter carries them in a pouch of folded hide attached to his belt, not scattered loose, not carried in his hands, but organized. Specific tools for specific tasks. This organizational behavior is itself significant. A 2016 study by Nama Goren Inbar at the Hebrew University of Jerusalem analyzed the spatial organization of Neanderthal tool assemblages at multiple sites and found consistent patterns of tool placement relative to hearths and activity areas. Patterns suggesting that Neanderthals organized their living and working spaces in ways that reflect forward planning and categorical thinking about different types of tasks. He carries scrapers, notched flakes for working around bone, a backed piece, a flake with one edge deliberately blunted so it can be held firmly without cutting the hand for the heavier work, and several small razor-edged cutting flakes, the kind of tool that modern experimental archaeologists consistently describe as more efficient for precise cutting work than modern steel scalpels. The first task is access. Before any serious butchery can begin, the animal must be positioned correctly. A juvenile mammoth lying on its side in a riverbed presents a logistical problem. It weighs 600 kilograms. Its limbs are stiffening in the cold, and the most nutritionally valuable parts of the carcass are not the parts that are easiest to reach. The three hunters work together, using the spear shafts as levers where necessary, repositioning the carcass to give the best access to the main muscle groups of the hindquarters and the thorax. This is physical work on a scale that is difficult to convey. Moving 600 kilograms of dead weight in the cold on frozen gravel with tools made of wood and stone and sinew. The younger hunter's arm is bleeding steadily. He has tied a strip of hide around it, not loosely, tight, in a way that suggests he understands the principle of pressure, though the word tourniquet does not exist in any language yet spoken on Earth. The hide comes off first. This is critical, and it is not simple. Mammoth hide is extraordinarily thick, up to 3 centimeters in places, and removing it cleanly without damaging the valuable inner surface that will be processed into clothing and containers requires patience and skill. The backed cutting flake moves in short, controlled strokes along the natural seam lines between skin and subcutaneous fat. The experienced hunter works the hindquarter. The broad-shouldered figure works the flank. The youngest, impeded by his injured arm, works more slowly on the shoulder, but he does not stop. The technique they are using has a name in modern archaeology. It is called systematic butchery, and it leaves a characteristic signature on bones, a specific pattern of cut marks at specific anatomical locations that reflects a consistent, taut, reproduced sequence of actions rather than random opportunistic hacking. These cut mark signatures are found at Neanderthal sites across Europe and the Near East, and they are consistent enough across time and geography that researchers can use them to reconstruct butchery sequences in remarkable detail. A study by Yolanda Fernandez-Halvo and Peter Andrews, published in the Journal of Human Evolution, analyzed cut mark patterns on animal bones from multiple Neanderthal sites and demonstrated that the butchery sequences represented were sophisticated, efficient, and anatomically informed. The marks on leg bones show disarticulation at specific joint surfaces. The marks on ribs show removal of meat in long strips rather than inefficient hacking. The marks near vertebrae show careful separation of the tenderloin, the most energy-dense muscle in the body, from the surrounding connective tissue. They knew what they were doing. They had always known what they were doing. The fat comes next, and fat is not an afterthought. Fat is survival. In the caloric mathematics of Pleistocene winter hunting, fat is more valuable than protein. It contains more than twice the calories per gram, it metabolizes into heat more efficiently, and for a species requiring 4,000 to 5,000 calories per day in cold conditions, a single juvenile mammoth represents several days of survival margin for a small group. The subcutaneous fat of a woolly mammoth, insulation adapted to subarctic cold, is thick and rich, and the hunters remove it carefully in slabs, setting it aside on a clean section of hide laid out on the gravel. Research on the diets of Neanderthals has come a long way from the early assumption that they were primarily or exclusively meat-eaters. Isotopic analysis of Neanderthal bones, measuring the ratios of carbon and nitrogen isotopes that reflect dietary sources, has produced a complex and regionally variable picture. A 2009 study by Michael Richards and colleagues, published in the Journal of Human Evolution, confirmed high levels of animal protein in the diets of many European Neanderthal populations, consistent with apex predator status in their ecosystems. But more recent work, including a 2020 study of dental calculus, the hardened plaque on Neanderthal teeth, published in Nature by Laura Wayrick and colleagues at the Australian Centre for Ancient DNA, found plant remains, starchy foods, and even medicinal plants in the dental record of Neanderthals from El Cedrón Cave in Spain. The picture that emerges is of a species whose diet varied significantly with geography and season. In the cold north during winter, the diet skewed heavily toward large animal fat and protein. In warmer, more vegetated environments, plant foods formed a meaningful component. This flexibility, this ability to exploit different food sources in different conditions, is itself a marker of cognitive and behavioral sophistication. Dietary generalism requires knowledge of multiple food types, their locations, their seasonality, their preparation requirements. In the frozen riverbed this morning, the diet is mammoth. Every part of the mammoth. The stomach is removed carefully and set aside, not discarded. The contents, partially digested vegetation, are not the target. The organ itself is. Stomach, intestines, liver, heart. These are the first foods consumed at a successful large kill by forager populations worldwide, and the reasons are physiological rather than cultural. These organs are extraordinarily rich in micronutrients, vitamins A, B12, D, and K, iron, zinc, folate, that are difficult or impossible to obtain in sufficient quantities from muscle meat alone. A diet of pure muscle meat without organs or fat leads to a condition known as rabbit starvation, protein toxicity, paradoxically, in which the body is overwhelmed by protein it cannot process in the absence of fat and micronutrients. Indigenous hunters from the Arctic to southern Africa have understood this for millennia. The Neanderthals, hunting large game in a cold environment for hundreds of thousands of years, understood it long before. The liver goes to the experienced hunter first. He eats it raw, warm, standing in the riverbed, cutting slices with the small backed flake and eating them directly from the blade. He does not cook it. There is no fire here, and there is no time. And besides, cooking liver reduces its vitamin content by a measurable percentage that no Neanderthal has ever calculated, but that the body understands empirically. Raw liver feels different than cooked liver. It satisfies a specific hunger that cooked meat does not. The younger hunter eats next, then the broad-shouldered figure. They work and eat simultaneously for the next 2 hours. It is not pretty. It is not ceremonial. It is efficient. Each of them is consuming somewhere between 800 and 1,000 calories in this first phase of eating, calories their bodies need desperately after a morning of extreme physical exertion in the cold. The blood, the smell, the steam from the open carcass, none of this is registered as unpleasant. It is registered as warmth, as continuation, as the difference between the morning and the afternoon. But they are not eating everything they can carry. This is the detail that matters most. They are not eating everything they can carry because they are not hunting for themselves alone. Back at the place we have not yet visited, the shelter, the camp, the home, whatever word fits a Neanderthal living site, there are others. How many we cannot say with certainty for this specific group. But the archaeological record gives us a picture of Neanderthal group sizes that has been significantly revised upward over the last 2 decades. Early estimates, based partly on assumptions about cognitive limitations, suggested that Neanderthals lived in very small, isolated bands of perhaps 5 to 10 individuals. More recent analyses, including genetic studies of Neanderthal populations published by Svante Pääbo's group at the Max Planck Institute for Evolutionary Anthropology, suggest a more complex picture. Small core groups, yes, but with evidence of regular contact between groups, interbreeding across significant geographic distances, and the kind of social network structure that implies a wider community beyond the immediate hunting party. At the site of Shanidar Cave in Iraqi Kurdistan, excavated first by Ralph Solecki in the 1950s and 60s, and revisited by a team from the University of Cambridge beginning in 2015, the remains of multiple Neanderthal individuals were found in close association, adults, a juvenile, an infant, suggesting that Neanderthals lived in mixed-age family groups. One individual at Shanidar, known as Shanidar 1 and sometimes called Nandy by researchers who have spent years with his bones, survived to old age with injuries that would have been permanently debilitating. A withered right arm, possibly amputated or lost in injury, healed fractures of the skull and eye socket, severe arthritis, degeneration of the leg bones consistent with a significant limp. He could not have hunted. He could not have gathered effectively. He survived for years, perhaps decades, in a condition of significant physical dependency. Something kept him alive. Someone kept him alive. The implications of Shanidar 1 are not subtle. They have been debated. Some researchers have argued that the injuries are less severe than initially described, or that survival with disability is not necessarily evidence of deliberate care. But the broader pattern, across multiple Neanderthal sites of individuals with healed severe injuries who demonstrably survived long after those injuries would have been fatal without assistance, points in one direction. Neanderthals took care of each other, not occasionally, not accidentally, as a pattern of behavior with enough regularity to leave a mark in the fossil record. In the riverbed, the experienced hunter is making a calculation. He looks at what remains of the carcass after the first phase of processing. He looks at the sky, reading the weather with the same automatic precision he applied to reading the wind this morning. He looks at his companions. The camp is not close. It is perhaps 4 kilometers to the northwest in a rock shelter at the base of a limestone cliff that faces south. South-facing, always south-facing, because south-facing shelters receive more winter sun, and more winter sun means a few degrees of warmth that the difference between sleeping and not sleeping in temperatures that drop to -15 at night. 4 kilometers with loaded packs in the cold across terrain that includes the frozen river crossing and a long slope through pine woodland. They will need to make 2 trips, or they will need help. The experienced hunter turns to the youngest member of the party and says something. We do not know what he says. We do not know what language he says it in. But the youngest member of the party sets down his butchering tool, picks up his spear, and begins moving northwest through the riverbed, moving fast, back toward the camp. He is going for help. He will be back in perhaps an hour and a half, perhaps 2 hours, with whoever can be spared from the camp to carry meat back through the cold. And in the meantime, the 2 remaining hunters will continue processing the carcass, working against the cold and against time, because there are other things in this landscape that can smell blood on the wind, and some of them are considerably larger than a Neanderthal. He smells it before he hears it. The experienced hunter is working on the left hindquarter, his backed flake moving in the short, precise strokes that separate the major muscle groups from the pelvis, when something in the air changes. It is not a loud change. It is not dramatic. It is the addition of a single new molecule of information to the cold morning air. A deep, musky, faintly ammonia-tinged scent that his brain identifies before his conscious mind has time to name it. He straightens slowly, does not look directly toward the tree line to the north, looks slightly to the side of it because peripheral vision detects movement more effectively than direct gaze, and this is not the kind of morning where you want to be wrong about movement. The broad-shouldered figure, working on the opposite side of the carcass, has already stopped. He is completely still, his heavy-hafted spear in his right hand, the blade of his butchering flake catching the pale winter light. They have company. What is watching them from the tree line to the north is a cave lion, Panthera spelaea, the cave lion of the Pleistocene. Not a metaphor, not an exaggeration, not a creature inflated by the distortions of deep time. A real animal, standing at the edge of the frozen pine woodland, watching 2 Neanderthals and 600 kilograms of fresh mammoth carcass with the patient, calculating attention of a predator at the top of its own food chain. And it is larger than any lion alive today. The African lion, Panthera leo, is the largest living cat in the world, outside of tigers. A large male can reach 250 kilograms. The cave lion of the Pleistocene, based on skeletal remains recovered from sites across Europe and Russia, was approximately 10 to 12% larger than its modern African relative. That is not a trivial difference. It translates to a body mass of somewhere between 270 and 300 kilograms, the size of a large black bear, but built with the predatory geometry of a cat. long-limbed, deep-chested, with forelimbs carrying the leverage for the kind of strike that can break the neck of a horse. The cave lion did not have the elaborate mane of the modern African lion. The cave paintings at Chauvet and Lascaux, which depict cave lions with extraordinary naturalistic accuracy, consistently show animals without manes, with subtler facial features, and with a body shape that is slightly more elongated than their African cousins. These paintings are not guesswork. They are observational records made by people who watched these animals in life. The artists who painted the lions at Chauvet Cave approximately 36,000 years ago were painting from direct experience, and what they recorded was precise enough that modern zoologists can use the paintings to make inferences about cave lion behavior and morphology. The paintings show, in several cases, groups of cave lions hunting together. This is significant. Modern lions are the only truly social cats, and their cooperative hunting is what allows them to take prey far larger than any individual could manage alone. If cave lions also hunted cooperatively, and the Chauvet paintings suggest they did, then what is watching from the tree line may not be alone. The experienced hunter scans the tree line without moving his head. He uses his eyes, moving them slowly across the shadows between the trunks, looking for the specific quality of stillness that a large cat achieves, a stillness that is different from the stillness of rock or bark, a stillness that has weight and intention behind it. He counts. 1 visible animal. 2 places in the tree line where the shadow was wrong. 3 lions, almost certainly. The situation is this. He and the broad-shouldered figure are standing in an open riverbed with a fresh carcass between them. The riverbed offers no cover and no elevated ground. The bank behind them, the one the juvenile mammoth went over this morning, is 2 meters high, climbable, but not quickly, and not without turning their backs on what is in the tree line. The youngest member of the party left 40 minutes ago and is not coming back for at least an hour. They have 2 spears and a collection of butchering tools between them. What they do next has been documented in its essential structure at multiple archaeological sites, and it is one of the most remarkable pieces of evidence for Neanderthal cognitive sophistication in the entire fossil record. They do not run. Running from a large cat in an open space is a death sentence. Every predator-prey interaction specialist alive understands this. Running triggers the chase response in a feline predator with the automaticity of a reflex. It is not a decision the lion makes. It is a cascade of neurological events that begins with the visual stimulus of fleeing prey and ends with acceleration. 300 kilograms of cave lion at full sprint can cover 10 meters per second. A Neanderthal at full sprint covers perhaps 6. The mathematics are not survivable. They stand their ground. More than that, they advance. Not quickly, not aggressively, but they move toward the tree line, together, staying close enough that their bodies overlap in the lion's visual field, making themselves look larger, and the experienced hunter does something that researchers studying predator deterrence in modern contexts have documented across multiple human cultures independently. He makes noise. Not screaming, not random noise. A specific, low, rhythmic sound, something between a shout and a chant delivered from the chest, designed to carry and to suggest something larger than what is actually standing in the riverbed. The broad-shouldered figure joins it a beat later, and together the sound they make resonates off the limestone valley walls in a way that is genuinely difficult to locate or assess. The visible lion takes 1 step back. This is, in the language of predator-prey interaction, the most important thing that will happen in the next 5 minutes. 1 step back. It is not retreat, Not yet, but it is recalibration. The lion is reassessing, and a lion that is reassessing is a lion that has not yet committed, which means a lion that can still be persuaded to find a less complicated meal. There is direct archaeological evidence for exactly this kind of confrontation. At the site of Combe Grenal in France, the analysis of cave lion bones alongside Neanderthal tools and cut-marked prey bones suggests repeated overlap between Neanderthal and cave lion occupation of the same space. Not predator-prey overlap, but competitor overlap. The cut mark patterns on the lion bones at some of these sites are consistent with skinning, which means Neanderthals were not just surviving encounters with cave lions, they were killing them, taking their hides, using their bodies as resources. A cave lion skin in the middle of a Pleistocene winter is a resource of extraordinary value. The fur is dense and insulating in ways that even mammoth hide cannot fully replicate for certain applications. Lighter, more flexible, easier to work into close-fitting garments. The sinew is long and strong. The claws and teeth, as we know from sites like Krapina, carried symbolic value that extended beyond their utility. Killing a cave lion is not an accident. It is not self-defense refined into opportunity after the fact. It is a planned, deliberate undertaking requiring exactly the combination of patience, coordination, and controlled aggression that these two figures are now displaying at the edge of a frozen riverbed. But this morning, with the youngest member of their party absent and their primary task unfinished, killing the lion is not the goal. The goal is simpler. The goal is to hold the line long enough for the situation to resolve. The two hunters continue their slow advance. The noise continues. The broad-shouldered figure raises his spear, not to throw, but to display, holding it high and horizontal, making the silhouette of the two figures wider and more complex. This is threat display behavior, and it is something that requires the ability to think from the lion's perspective, to model, however approximately, what the lion sees and what that sight communicates. That capacity to model another mind's perceptual experience is what cognitive scientists call theory of mind. It is the ability to understand that other beings have their own perspective, their own knowledge state, their own point of view, which may differ from your own. It is considered by many researchers to be one of the foundational capacities underlying complex social behavior, language, cooperation, and culture. For a long time, it was assumed to be uniquely or near uniquely human. The Neanderthal raising his spear to look bigger to a lion is using theory of mind as naturally as breathing. The standoff lasts 11 minutes. 11 minutes of slow advance, sustained vocalization, and weapon display. 11 minutes of two individuals maintaining coordinated behavior under extreme stress, without breaking, without panicking, without separating. And at the end of those 11 minutes, the visible lion turns and walks back into the tree line. Not quickly, with the careful, unhurried dignity of a predator that has decided on its own terms that this particular situation is not worth the investment. The shadows in the tree line that were wrong gradually become right again. The two hunters stand at the edge of the pines for another full minute, listening, before they turn and walk back to the carcass. They do not celebrate. They do not collapse with relief. They pick up their butchering tools and go back to work, because the carcass is getting cold, and the fat is starting to stiffen, and there is still an enormous amount to do before anyone from the camp arrives. But something has just happened that deserves a moment of reflection. Two individuals without modern weapons, without fire, without any of the technological scaffolding that modern humans reach for automatically in moments of danger, faced down three cave lions over a fresh mammoth kill and walked back to their work. They were not lucky. Luck is not a strategy that survives across hundreds of thousands of years. They were competent. They were trained in the deepest sense of the word. Not trained by a school or an instructor, but trained by the accumulated experience of a lineage that had been negotiating exactly these encounters in exactly these landscapes for longer than our entire species has existed. We should sit with that for a moment. Homo sapiens, anatomically modern humans, appear in the fossil record at roughly 300,000 years ago in Africa. The Neanderthal lineage had been living in Europe and Western Asia for somewhere between 400,000 and 700,000 years before that, depending on how you define the beginning of the lineage. They had been hunting large, dangerous prey in cold environments, competing with cave lions and cave hyenas and cave bears and dire wolves, animals that no modern human has ever faced in the wild, for longer than our own species has existed anywhere on Earth. The competence embedded in those two figures in the riverbed is not improvised. It is ancient. It is the distilled result of more generations of trial and error than the mind can comfortably hold. And now, approximately 32,000 years ago, it is running out of time. Because somewhere to the south and east, moving through the same landscape, following the same herds, sheltering in the same south-facing limestone overhangs, are members of a different species. One that has been in Europe for perhaps 10,000 years, a blink of an eye compared to the Neanderthal tenure. One that is anatomically similar enough that the two species will, on some occasions and in some places, interbreed successfully and produce offspring who carry genetic material from both lineages. One that will, within a few thousand years, be the only hominin left standing on the planet. The relationship between Neanderthals and incoming Homo sapiens is the most contested and most emotionally charged question in all of human origins research. For decades, the dominant narrative was one of replacement. The moderns arrived, they were smarter, faster, better equipped culturally and cognitively, and the Neanderthals simply could not compete. This narrative was satisfying in its clarity and deeply problematic in its assumptions, many of which were rooted less in evidence than in a very human desire to see ourselves as the inevitable optimal outcome of evolution. The evidence, accumulated over the last 20 years, tells a more complicated story. The interbreeding is real. The genetic contribution of Neanderthals to modern non-African human populations, first demonstrated by Svante Pääbo's team at the Max Planck Institute in their landmark 2010 paper in Science, and refined many times since, is real and measurable. Some Neanderthal gene variants that survived in modern human populations are associated with immune function, suggesting that Neanderthal genetic contributions may have helped modern humans survive pathogens they encountered in Europe that Neanderthals had already adapted to. Others are associated with skin and hair characteristics. The precise functional significance of each inherited variant is still being worked out in ongoing research that produces new findings every year. The moderns and the Neanderthals met. They exchanged genes. They may have exchanged more than genes. There is evidence, still debated, of technological and cultural exchange between the two species in the Châtel-Péronian period, when Neanderthals in France and Spain began producing ornaments and modified tools that look, in some respects, like those associated with modern humans further east. Did the Neanderthals invent these independently? Did they copy them? Did they receive them through trade or through interbreeding with individuals who brought new knowledge? The answer may be different at different sites and different times. What ended the Neanderthals is not a simple story, and anyone who tells you it is simple is selling you something. Climate change played a role. The climatic fluctuations of the late Pleistocene were severe and rapid, and each cold pulse compressed the available habitat. Competition with modern humans played a role. Not necessarily violent competition, though violence certainly occurred, but ecological competition for the same prey animals in the same landscapes. Disease may have played a role. Populations encountering new pathogens for which they have no immunity are devastated in ways that have nothing to do with intelligence or cultural sophistication, as history demonstrates repeatedly. Small population sizes, already a feature of Neanderthal demographics, made recovery from any of these pressures hard. The last Neanderthals, based on current dating evidence, disappeared from the archaeological record approximately 40,000 years ago, though a site in Gibraltar, Gorham's Cave, has produced evidence possibly suggesting Neanderthal presence as recently as 28,000 years ago, a date that remains scientifically controversial. They did not go quietly. They had been here for hundreds of thousands of years, and they went the way all species eventually go. Not with a final dramatic scene, but with a gradual thinning, a slow reduction in the number of fires lit in the winter dark, until one night, the last fire went out and was not relit. But that ending is not today. Today, in the frozen riverbed, the carcass is being processed with skill and efficiency. The cave lions are gone. The cold is manageable. And from the northwest, moving fast through the pine woodland, come voices. Not many, 3 or 4, and the youngest hunter is in front of them, his injured arm wrapped and held close to his body, his breath coming fast from the pace he has maintained since he left. Behind him, 2 adults from the camp, and one more figure, smaller, moving carefully on the icy ground. We will meet them at the camp. We will follow the hunting party back through the cold, loaded with meat and fat and hide, and we will arrive at the place that is, in every sense that matters, home. And in that place, we will find the most quietly devastating evidence of all. The evidence that has forced even the most skeptical researchers to reconsider everything they thought they knew about what kind of creature a Neanderthal truly was. The rock shelter faces south. This is not coincidence. This is not accident. This is the result of a selection process played out over hundreds of thousands of years of Neanderthal occupation of limestone landscapes. A process that encoded in the behavior of every individual who participated in it a simple and powerful truth. South-facing rock means more sunlight, more warmth, and the difference between a shelter that is survivable in February and one that is not. The limestone cliff behind the shelter rises approximately 15 meters. The overhang projects 4 meters outward from the cliff face, creating a protected space roughly 12 meters wide and 8 meters deep, enough for a small group to sleep, work, eat, and maintain a fire without being directly exposed to wind or precipitation. The floor of the shelter is not natural. It has been modified. Not dramatically, not with the kind of earth-moving that implies specialized tools or organized labor, but consistently. Rocks have been cleared from the central area, moved to the perimeter, creating a flatter surface. Sediment has accumulated over what may be years of occupation, layered with ash and charred bone and discarded flint, building up into a floor that is softer and more insulating than the bare limestone beneath. This is what archaeologists call a living floor, and the ones that survive At sites including Abric Romani in Catalonia, Kibara Cave in Israel, and Grotte du Lazaret in southern France, are among the most intimate and detailed records of Neanderthal daily life that exist anywhere in the fossil record. At Abric Romani, excavated by Eudald Carbonell and colleagues over decades of meticulous work, more than 60 distinct hearths have been identified across multiple occupation layers. The spatial organization of these hearths, their relationship to each other, to concentrations of tools and food remains, to areas of burnt and unburnt bone, has allowed researchers to reconstruct with remarkable granularity how the space was used, where food was processed, where tools were made, where people slept. The hearth at the center of this shelter has been burning in various states of intensity for what the charcoal layers in the sediment suggest is several continuous weeks. It is not a large fire. It does not need to be large. A small, well-maintained fire in an enclosed rock shelter creates a microclimate that can raise ambient temperature by 10 degrees or more above the outside air. The Neanderthals who maintain it understand this empirically. They understand that a fire fed steadily with dense hardwood holds heat longer than one fed with softwood, that a fire banked with ash retains coals through the night, that a fire positioned at the back of the shelter uses the cliff face as a heat reflector in a way that a fire at the front does not. Neanderthal fire use was not opportunistic. It was not limited to exploiting naturally occurring fires and tending them until they died. The evidence for deliberate fire-making by Neanderthals, the production of fire from scratch using percussive methods, has accumulated steadily over the last 2 decades. A 2018 study by Andrew Sorensen at Leiden University, published in Scientific Reports, analyzed handheld stone tools from multiple Neanderthal sites in France and Germany and found traces of iron pyrite residue on their surfaces, combined with impact damage consistent with striking flint against pyrite to produce sparks. The tools were fire-making kits. They had been used repeatedly, maintained, and carried, not left behind, not treated as disposable, but curated as valuable equipment. Neanderthals made fire. They carried the means to make fire with them. They managed fire across weeks and months of continuous occupation. The fire at the center of this shelter is tended right now by someone who did not go on the hunt this morning. She is not young. The wear on her teeth, visible in the slight forward projection of her incisors, ground down by decades of using her mouth as a third hand in the way we noted earlier, places her somewhere past what might loosely be called middle age for a Neanderthal, which is to say past 35, which in this world and this body represents a considerable accumulation of time and damage and survival. Her left hand shows the healed remnants of an old injury, 2 fingers that knitted crookedly after a break, reducing her grip strength on that side but not eliminating it. She compensates with her right hand in the way that people compensate for long-healed injuries, automatically, without awareness. She is working on a piece of hide. Not the hide from this morning's kill, that has not arrived yet. An older piece, stiff and partially dried, that she is softening through a combination of moisture and mechanical work, pulling it repeatedly over a bone tool, working the fibers apart. The technique is called hide graining, and it is the most labor-intensive part of the entire process of turning an animal hide into something that can be worn. Experimental archaeology has demonstrated that processing a single large hide by hand, from fresh to finished, requires somewhere between 8 and 12 hours of sustained physical effort. This effort is not glamorous. It is not dramatic. It does not leave the kind of clear, unambiguous archaeological signature that a hafted spear point leaves. But without it, the group dies in February. The hide she is working will become or will contribute material to, clothing. And Neanderthal clothing is another of those topics where the revision of earlier assumptions has been quiet but profound. For a long time, the image of Neanderthals in crude, roughly draped animal skins persisted in popular imagination and, to a lesser extent, in scientific discussion. The assumption was that clothing, like so many other things, was a modern human innovation, that Neanderthals managed the cold through their physiology rather than their technology. The physiology is real. The Neanderthal body plan, short limbs relative to torso, dense muscle mass, large nasal passages for warming air, is a cold-adapted body plan, and it provided genuine thermoregulatory advantages over the taller, more linear body of tropical Homo sapiens. But physiology alone is not enough to survive -15 degrees Celsius at night in a Pleistocene winter. Not for any mammal without a fur coat. A 2016 study by Nathan Wales at the University of Copenhagen used thermal modeling to calculate the minimum insulation requirements for a Neanderthal body in the climate conditions of Northern Europe during glacial periods. The conclusion was unambiguous. Neanderthals needed clothing. Not occasionally, not as a supplement to physiological cold tolerance, as a survival requirement. The model suggested that clothing covering at least 80% of the body surface would be necessary to maintain core temperature during winter nights. The clothing existed. The lice tell us it did. Body lice, Pediculus humanus, are a human-specific parasite that evolved from head lice when their ancestors first colonized the seams of clothing, where they lay their eggs. The genetic divergence between head lice and body lice has been dated, in research published by David Reed and colleagues, to approximately 170,000 years ago. This date precedes the arrival of modern humans in Europe and suggests that clothing with seams, complex, tailored clothing, not just draped skins, existed before Homo sapiens became the dominant hominin on the planet. The question of who was wearing that clothing 170,000 years ago has an obvious answer. Near the fire to the left, two smaller figures sit close together. One is perhaps 7 or 8 years old in human developmental terms, a rough estimate because Neanderthal childhood development was faster than modern human development, reaching physical maturity earlier, spending less time in the extended period of dependency that characterizes our own species' life history. The other is younger, perhaps 4, sitting with the concentrated attention of a small child doing something with their hands. A piece of flint, too large to be dangerous, being turned over and over in the small fingers with the exploratory focus of a mind that is learning the properties of stone through direct physical engagement. This is not idle play. This is apprenticeship. The handling of stone, the development of the fine motor skills and spatial reasoning required to eventually produce tools, begins early and begins through exactly this kind of unsupervised, exploratory contact with raw materials. Research by Dietrich Stout at Emory University, using neuroimaging to study the brain activity of modern humans learning to knap stone, has demonstrated that stone tool production engages overlapping neural circuits with language production. Both require hierarchical, sequential planning across multiple levels of abstraction simultaneously. The implication is that the cognitive architecture for tool making and the cognitive architecture for complex language may be more deeply intertwined than previously understood. The 4-year-old turning a piece of flint in small hands is in some sense learning to think. And then, from the woodland to the southeast, voices. The woman tending the hide looks up. Her posture changes. Not alarmed, but attentive. The 2 children look toward the entrance of the shelter. The older one gets up and moves to the edge of the overhang, looking out across the slope of frozen pine needles that descends from the shelter toward the tree line. They come out of the trees in single file, moving carefully on the icy slope. The youngest hunter first, his injured arm wrapped and held at his side, his breath coming in visible clouds. Behind him, two adults from the camp, a man and a woman, carrying between them the first load of meat from the carcass, wrapped in sections of hide and bound with sinew. Their packs are not comfortable. They are heavy, awkward, and they have been carried 4 kilometers across terrain that includes a frozen river crossing and a long climb through pine woodland. Behind them, the experienced hunter, and behind him, the broad-shouldered figure. They are all carrying something. Every person capable of carrying something is carrying something. This distribution of load, this immediate automatic mobilization of everyone who can contribute to moving the resource from where it is to where it needs to be, is not organized by command. There is no chief directing operations. The organization emerges from shared understanding of what needs to happen, and it emerges quickly, because it has happened before, many times, in the specific way that repetition encodes expectation into behavior. The woman tending the hide has already moved to the fire. She adds wood, a specific size of wood, dense and dry, that she has been keeping back from a store at the rear of the shelter, not because she was told to, because she knows what a successful hunt means in terms of what the returning hunters need, and what they need right now is heat. The meat comes into the shelter and goes immediately near the fire, not to cook, not yet, but to begin the process of thawing from the deep cold it has accumulated during the carry. The packs are unwrapped. The portions of fat, kept separate, go to a specific location at the back of the shelter. The hide sections are stacked near the woman who was working the older hide. The youngest hunter sits down near the fire. The woman who was tending it looks at his arm, and without a word being exchanged that we can hear, she moves to a bundle near the rear of the shelter and removes from it something that the archaeological record, in the form of dental calculus analysis, has taught us to expect. Plants. The dental calculus study published by Laura Weyrick and colleagues in 2017 in Nature, analyzing Neanderthals from El Cedrón Cave in Spain, found evidence in the dental plaque of penicillium mold, a natural source of antibiotic compounds, and of Achillea, the genus that includes yarrow, a plant with documented anti-inflammatory and wound-healing properties used in traditional medicine across dozens of cultures worldwide. The same study found evidence of poplar bark, which contains salicin, the compound from which aspirin is derived. The Neanderthal at El Cedrón who was consuming these plants was, according to the isotopic analysis of his bones, an individual with a serious dental abscess. He was, the researchers concluded, self-medicating. The woman unwrapping the bundle near the fire knows things about plants that no university currently teaches. She knows which bark reduces fever. She knows which leaves, chewed and applied, slow bleeding. She knows these things the way she knows which side of the shelter faces south, not as abstract propositions, but as embodied knowledge inseparable from the experience of having used them, having seen them used, having learned them from someone who learned them from someone before. She applies something to the gash on the youngest hunter's forearm. He does not pull away. The older child watches carefully, with the specific quality of attention that distinguishes observation that is storing information from observation that is merely passing time. The experienced hunter sits near the fire. He takes a piece of meat, already beginning to thaw at its edges, and holds it near enough to the flame to warm it without cooking it through. He eats slowly, without urgency, the way a body eats when it has done a great deal of work and needs to refuel carefully, rather than overwhelm a depleted system all at once. The fire pops and settles. Outside, the light is changing. The pale winter sun has passed its low apex and is already beginning its early descent toward the southwestern horizon. In this latitude, in this season, darkness comes by mid-afternoon. The temperature outside the shelter is already dropping toward the evening's low, and the wind has come back from the northeast, pushing through the pine tops with a sound like distant water. Inside the shelter, it is warm. Not comfortable by modern standards, not private, not quiet. The smell of the space, fire smoke, rendered fat, unwashed bodies, cured hide, the mineral tang of stone dust from tool making, is dense and specific, and would be overwhelming to a modern human walking in from outside. But it is the smell of survival. It is the smell of the inside of something, rather than the outside. It is the smell of a place that has been occupied and tended and returned to over and over, until the act of returning to it has become one of the deepest satisfactions available in this world. The 4-year-old has abandoned the piece of flint and has moved to sit against the broad-shouldered figure, leaning against his side with the boneless confidence of a small child who knows exactly where safety is located in space. The broad-shouldered figure puts one heavy arm around the small body without looking down. He is watching the fire, and in the watching of the fire, in this specific posture, in this specific warmth, in this specific enclosure of stone and shadow and shared breath, something is happening that we have not yet named. Something that the archaeological record can gesture toward, but cannot fully capture. Something that makes the next chapter of this story the most important and the most humbling of all. Because what happens in a Neanderthal shelter after dark is not only eating and sleeping. Something else happens. Something that, when we finally found the evidence for it, forced even the most cautious researchers to ask a question that science is not always comfortable asking. What did Neanderthals feel? Darkness comes fast in a Pleistocene winter. One moment, the entrance to the shelter frames a rectangle of gray-blue light, pine silhouettes sharp against a pale sky. The next, the light is gone, pulled away like a cloth from a table, and the world outside the overhang becomes a single, uniform darkness that has no bottom and no edge. The temperature drops 4 degrees in 20 minutes. The wind drops with it, settling into the particular dead stillness of a very cold night, where the air is too dense and too frozen to move easily. Inside the shelter, the fire is everything. Not metaphorically, literally. It is the light source, the heat source, the cooking apparatus, the social center, and the psychological anchor of the entire group. Remove the fire, and this space becomes a cold limestone cave in the dark, indistinguishable in its hostility from the open ground outside. Maintain the fire, and it is something else entirely. Something that has a name in every human language that has ever existed. A name that means safety and warmth and the presence of others. Home. The meat is cooking now. Not all of it. Most of what came back from the carcass has been stored at the rear of the shelter, in the cold that accumulates there away from the fire, where it will freeze solid overnight and keep for days. But several pieces have been placed directly in the coals or suspended above them on wooden supports jammed between rocks, and the smell that fills the shelter is the oldest smell in the human sensory vocabulary. Rendering fat, charring protein, the Maillard reaction happening in the flesh of a woolly mammoth over a fire made by Neanderthal hands 40,000 years ago. There is, embedded in that smell, a history so long it defeats imagination. Controlled fire use in the hominin lineage stretches back at least 1 million years based on evidence from Wonderwork Cave in South Africa. Some researchers argue for earlier dates. The cooking of food, the application of heat to make nutrients more bioavailable, to kill pathogens, to soften tough connective tissue, may have been a driver of brain expansion in our lineage, as Richard Wrangham of Harvard University has argued in his cooking hypothesis, a proposal that remains influential and contested in equal measure. By the time of the Neanderthals, fire is not new technology. It is an inheritance so old that the brain has been shaped by it. The digestive system has been shaped by it. The social life has been shaped by it, because a fire that must be maintained creates a reason to stay in one place, and a reason to stay in one place creates the conditions for everything that happens when a group of intelligent social animals sits together in the dark and is not immediately required to do anything. The group settles. The injured hunter's arm has been cleaned and dressed, and he is leaning against the wall of the shelter with the specific boneless quality of someone whose body has spent everything it has and is now demanding the bill be paid. The broad-shouldered figure is working on a stone core by firelight, not producing finished tools, but preparing the core for tomorrow's knapping, a task that requires good light and steady hands, and is being accomplished with the automatic competence of someone who has done it 10,000 times. The older child sits close to him, watching the hands, the eyes tracking each strike with the focused attention we noted earlier. The woman who tended the fire and dressed the wound is doing something that, when researchers first encountered the evidence for it at Neanderthal sites, generated a debate that has not fully resolved to this day. She is applying ochre to a piece of hide. Red ochre, iron oxide, hematite in its powdered form, has been found at Neanderthal sites across Europe, the Near East, and North Africa in quantities and contexts that resist purely utilitarian explanation. At Maastricht Belvedere in the Netherlands, ochre was found at a site dating to approximately 250,000 years ago, one of the earliest documented uses of the mineral by any hominin in Europe. At Pec de la Zaye in France, Neanderthal sites contain ochre pieces with flat, ground surfaces, indicating that the mineral was being deliberately processed, ground against a harder stone to produce powder. At Cueva de los Aviones in Spain, pierced shells and lumps of pigment found in a context dating to approximately 115,000 years ago, a date that predates the arrival of modern humans in Europe by at least 60,000 years, suggest that Neanderthals were collecting, processing, and possibly applying pigments as part of some form of symbolic or decorative behavior. The utilitarian explanations have been proposed and tested. Ochre does have practical applications. It can be used as an adhesive component in hafting compound. It has mild preservative properties when applied to hide. It may have insect repellent effect. These explanations are not impossible. But at many sites, the quantity of ochre recovered and its association with specific objects rather than with general tool-making debris suggests something beyond pure utility. The ochre at these sites was not incidentally present. It was sought, transported sometimes over significant distances, processed, and used in ways that reflect choices. Choices about color, about application, about which objects received it and which did not. Choice implies preference. Preference implies aesthetics. And aesthetics, the experience of some things as more beautiful, more meaningful, more significant than others, is something we have, for a very long time, wanted to believe was exclusively ours. The woman applying ochre to the hide is not decorating it randomly. The strokes are deliberate. Whether what she is making constitutes art in any sense that connects to what we mean by that word is a question that cannot be answered from the hide itself, which will not survive. It can only be gestured at from the accumulated evidence of ochre-stained objects and pigment processing stones at dozens of Neanderthal sites across a span of 200,000 years. 200,000 years of ochre. That is not accident. That is not incidental contamination of the archaeological record. That is a behavior, transmitted across generations, persisting through climate shifts and population bottlenecks, and the extinction of prey species and every other disruption that a Pleistocene world could throw at a population of large-brained social mammals. Something about color, about mark-making, about the transformation of a plain surface into a marked one, mattered to Neanderthals. It mattered enough to carry the raw materials for it. It mattered enough to teach it. It mattered enough to keep doing it for longer than our entire species has existed. The fire pops and sends a brief shower of orange sparks toward the ceiling of the overhang. The 4-year-old, who has been drowsing against the broad-shouldered figure's side, opens its eyes briefly and watches the sparks die against the limestone, and then closes them again. The experienced hunter has not moved from his position near the fire. He is eating slowly, methodically, replacing what the morning took out of him. But he is also doing something else. He is talking, not constantly, not in the continuous, overlapping, dense social chatter that characterizes modern human groups at rest, in shorter bursts, with longer silences between them. But the sounds he produces are not grunts, not simple emotional vocalizations, not the limited repertoire of a creature without language. They have the prosodic structure, the rhythm and melody and patterned variation of pitch and duration that is a universal feature of human language across all known cultures, and that is, as far as we can tell from the anatomy and genetics, available to the Neanderthal vocal and neurological system. What he is talking about, we cannot know, but we can make educated inferences from what we know about the contexts in which language evolved and the functions it serves in forager societies studied by modern anthropologists. He may be recounting the hunt. This would be consistent with a near-universal feature of forager social life, the narration of significant events to group members who were not present, a behavior that serves multiple simultaneous functions. It updates the group's shared knowledge base. It reinforces the social bonds between participants and non-participants. It transmits tactical and ecological knowledge, what worked, what did not work, what the animals did, what the landscape looked like, where the lions were, in a form that can be stored in memory and retrieved in future contexts. It may, in some cases, involve something like evaluation or interpretation. Not just what happened, but what it meant, what it implies about tomorrow, what it suggests about the behavior of the prey animals in this part of the valley at this time of year. If Neanderthals had language capable of carrying this kind of content, and the anatomical and genetic evidence suggests the capability was present, then the information being transmitted around this fire tonight is not merely social. It is ecological. It is tactical. It is the living database of a group's accumulated knowledge about their landscape, being updated in real time, being distributed to all members, including those too young or too injured or too old to gather it directly. This is, in its essentials, what a school is, what a library is, what a news broadcast is. The technology is fire and voice rather than paper and electricity, but the function, the preservation and distribution of hard-won information across a group, is identical. Now, there is a burial site approximately 200 kilometers to the south and east of this shelter that has never been found. It will never be found. The limestone in which it sits will be dissolved by groundwater over the next 10,000 years, and the bones within it will disperse into the sediment without leaving the kind of concentrated, identifiable signature that paleontologists look for. But we know from dozens of other sites what it probably looks like. A shallow depression in the floor of a cave or rock shelter, deliberately excavated. The evidence for deliberate excavation comes from the contrast between the disturbed sediment of the pit and the undisturbed sediment around it. A body placed within it in a specific position, flexed, knees drawn toward the chest, in the position that cross-cultural studies of burial practices identify as the most common deliberate interment posture in pre-modern human populations worldwide. Ochre on the bones, or near them, and in some cases, Shanidar Cave being the most famous and most debated example. Pollen. The pollen of flowers. Ralph Selecki's original analysis of the Shanidar IV burial, published in Science in 1975, proposed that the pollen found in the sediment around the body represented flowers deliberately placed with the dead. A Neanderthal funeral with grave goods of blossoms. This interpretation was challenged by researcher Jeffrey Summer in 1999, who suggested that the pollen could have been introduced by burrowing rodents carrying plant material into the sediment. The debate has continued since. The 2023 reanalysis of new material from the Shanidar site, conducted by a Cambridge University team led by Emma Pomeroy and published in the Journal of Archaeological Science, found flower pollen again, in a new burial context, associated with a newly discovered individual, in a stratigraphic layer that makes the burrowing rodent explanation considerably more difficult to sustain. The debate is not over. Science is honest about what it does not yet know. But step back from the specific argument about specific pollen at a specific site and look at the broader pattern. Neanderthals placed their dead in specific locations. They dug pits. They positioned bodies carefully. They sometimes included objects with the dead. At La Chapelle-aux-Saints in France, the original site of the famous old man Neanderthal skeleton that did so much to shape early 20th century perceptions of the species, the body was placed in a pit that researchers have argued, in a 2014 study published in the Proceedings of the National Academy of Sciences, shows clear evidence of deliberate excavation. Deliberate burial means, at minimum, that the dead body was not simply left where it fell. It means that someone expended energy, physical energy in digging, and organizational energy in coordinating the activity, to place the dead in a specific way in a specific location. It means that the dead were treated differently from butchered prey animals, from discarded tools, from any other category of material in the environment. It means that death was, for Neanderthals, a category of experience that required a response beyond the practical. What that response meant to them, what concept of death, what understanding of the distinction between living and dead, what sense of the significance of a specific individual's absence, we cannot access directly. But that a response was required, and that the response was consistent enough across sites and times to constitute a recognizable pattern, is as close to certain as archaeology gets. They mourned, or they did something that, from the outside, looks indistinguishable from mourning. In the shelter, the fire is lower now. The experienced hunter has stopped talking. The broad-shouldered figure has set aside the stone core and is lying on his side near the fire, the 4-year-old curved against his chest, both of them still. The older child is asleep against the wall. The youngest hunter is deeply, heavily unconscious in the way of a body that has pushed past its limits and shut down completely. The woman who applied ochre to the hide is the last one awake. She is not doing anything in particular. She is looking at the fire in the way that fire invites being looked at, the specific, slightly unfocused gaze that a moving light source draws from a visual system calibrated for detecting movement in the dark. Researchers who study this phenomenon call it the fire focus, and it appears to be a near-universal feature of human psychology. Something about a controlled fire in darkness induces a state of relaxed attention, of open but undirected awareness that may have been the original context in which extended social reflection became possible. What she is thinking in that firelit awareness is inaccessible to us completely, and that inaccessibility is itself a kind of answer to the question of what she is. She is someone whose inner life we cannot reach, someone whose experience of this night, the warmth, the smell, the sound of breathing in the dark, the particular weight of what this day has been, is as real and as specific and as irreducibly individual as any experience being had by any person alive tonight, 40,000 years later, in the world that came after. That is not sentiment. That is the logical conclusion of the evidence. The fire settles into its lowest steady state. Outside, the temperature has dropped to -12. The stars over the limestone valley are extraordinary. No light pollution, no atmospheric haze of industry, just the full density of the Milky Way overhead, a river of cold light above a frozen world. Tomorrow there will be more to do. The rest of the carcass must be retrieved. The hide must be processed. Tools must be made and repaired. The group's movements through the landscape will need to be planned around what the weather is doing, and what the prey animals are doing, and what the territory to the north looks like, given that the cave lions were there this morning. But that is tomorrow. Tonight, in the rock shelter that faces south, the fire keeps its small, persistent promise. And the group that has built its survival around that fire sleeps in the particular safety of a place that has been chosen and maintained and returned to. A place that is theirs in the only sense that ownership meant anything in the Pleistocene. They are here. They are warm. They are fed. They are together. And somewhere in the limestone above them, molecules of ochre are settling into the surface of a rock wall. A mark made by a hand that will not be found for 40,000 years, if it is found at all. A mark that means something, even if we are not yet sure what. Before the last ember dies tonight, let us go somewhere else. Let us leave this shelter, this fire, these sleeping figures, and travel, not across space, but across time. Let us move forward through the years the way a river moves through a landscape, following the path of least resistance, carrying everything with it. 38,000 years ago, the same limestone country, the same river valley, the same south-facing overhangs and the same cliffs. But the fires are fewer. The sites that were occupied continuously for generations are now occupied intermittently, then occasionally, then not at all. The layers of ash and charred bone and discarded flint that built up over centuries of habitation thin out. The living floors that archaeologists will one day read like pages of a book become shorter chapters, then footnotes, then silence. 35,000 years ago, the Neanderthal range, which once stretched from Portugal in the west to Siberia in the east, from Britain in the north to the Levant in the south, has contracted. The northern populations are gone. The eastern populations are gone. What remains are pockets, isolated groups in refugia, the biological term for places where a retreating species holds on as its broader range collapses. The Iberian Peninsula, parts of the Balkans, the Rock of Gibraltar, where the Mediterranean meets the Atlantic in a narrow, wind-scoured passage, and where a cave called Gorham's faces the sea. 32,000 years ago. Perhaps less, perhaps more. The dating is imprecise, and the imprecision is itself significant. It reflects the difficulty of finding the boundary between presence and absence, between the last Neanderthal fire and the first night without one. And then, nothing. The question of why, the question that has generated more scientific argument, more competing hypotheses, more passionate disagreement than almost any other question in human origins research, is not a simple question with a simple answer. Anyone who tells you it is simple is not doing science. They are doing storytelling of a particular kind, the kind that trades accuracy for narrative satisfaction. So let us do science instead. Let us look at what we actually know, what we strongly suspect, and what remains genuinely unresolved. The climate was changing. This much is established beyond reasonable doubt. The late Pleistocene was characterized by rapid, severe climatic oscillations, shifts between cold stadials and warmer interstadials that could produce dramatic environmental change over timescales of decades rather than millennia. A 2020 study led by Michael Stabwasser at the University of Cologne, published in the Proceedings of the National Academy of Sciences, used cave stalagmite records from Romania and analyzed oxygen isotope ratios, a precise proxy for past temperature and precipitation, to identify two particularly severe cold events between 44,000 and 40,000 years ago, right at the time of Neanderthal disappearance. These events, which the researchers designated Heinrich Event 5 and a subsequent cooling episode, would have dramatically reduced the forest cover that Neanderthals depended on for shelter, ambush hunting, and plant food resources. Cold and dry conditions compress forest into isolated patches. Isolated patches fragment populations. Fragmented populations lose genetic diversity. Small, genetically impoverished populations are less resilient to disease, to reproductive failure, to the kind of bad luck that large populations absorb without consequence, but small ones cannot. This is the mathematics of extinction, and it operates independently of intelligence, culture, or capability. A species can be extraordinary and still fall to the arithmetic of small numbers. But climate alone does not fully explain the timing. Neanderthals had survived previous cold events. Their lineage had persisted through multiple glacial cycles, adapting each time, contracting and expanding with the habitat. Something about this particular contraction was different. Something about this particular period was the one they could not come back from. That something had a name. Several names, in fact, distributed across the landscape in small mobile groups, carrying tools made of bone and antler, as well as stone, wearing jewelry made of perforated shells and ivory beads, and painting the walls of caves with images of animals and hands and symbols that no one has yet fully deciphered. Homo sapiens had arrived in Europe. The overlap between the last Neanderthals and the first modern humans in Europe is a period that archaeology is only now beginning to map with real precision, using improved radiocarbon dating techniques and more careful stratigraphic analysis than was possible in earlier decades. The picture that is emerging is one of a mosaic, different regions at different times, some areas where the two species may have coexisted for thousands of years, others where the transition appears to have been rapid. The word coexisted requires careful handling. It does not necessarily mean peaceful coexistence. It does not necessarily mean violent replacement either. Both extremes have been proposed, and both extremes almost certainly oversimplify a situation that played out across thousands of years, hundreds of distinct populations, and an entire continent of varying landscapes and resources. What we can say with confidence is this: modern humans brought with them a technology that was, in certain specific respects, more flexible and more expandable than the Mousterian tradition. Not better in every dimension, The Levallois points carried by our Neanderthal hunter were, as we have established, extraordinary instruments. But the Upper Paleolithic technology of incoming Homo sapiens included blade production from prismatic cores that was faster and more material efficient than Levallois flaking. It included projectile technology, spear throwers, and possibly early bow-like devices that extended effective hunting range beyond what a thrown or thrust spear could achieve. It included bone and antler working at a level of complexity that the Mousterian tradition does not consistently demonstrate. Small technological advantages, compounded over generations in a context of direct ecological competition for the same prey animals in the same landscapes, produce outcomes that arithmetic makes inevitable. If two groups are hunting the same mammoth herds, and one group can take prey more efficiently or from safer distances or with weapons that are cheaper to produce and faster to replace, the herds decline faster for one group than for the other. The group with the margin starves last. The group that starves last wins in the bleak accounting of evolutionary competition, even if winning looks nothing like victory. But there is another dimension to this competition that is harder to quantify and potentially more significant than any specific technology: network size. A 2020 study by Henrik Muhlenberg and colleagues, using agent-based modeling to simulate the interaction between modern human and Neanderthal populations in late Pleistocene Europe, identified social network size as one of the most powerful predictors of competitive outcome. Modern human populations, the model suggested, maintained larger, more connected networks. More frequent contact between groups, longer-range exchange relationships, more individuals within information-sharing distance of any given individual. This network advantage translates directly into resilience and innovation speed. A new technique, a new solution to a resource problem, a new understanding of a prey animal's behavior. In a large connected network, this information spreads rapidly, is tested in multiple contexts, is refined through multiple iterations, and becomes available to a large population quickly. In a small, isolated network, it may die with the individual who discovered it, or remain confined to a single group, or spread so slowly that it arrives after the crisis it could have solved has already done its damage. The Neanderthal social network, as we have established, was not absent. The genetic evidence shows gene flow between groups separated by significant distances. The technological traditions show enough consistency across geography and time to indicate transmission of knowledge between populations. But the evidence, including the genetic evidence for low Neanderthal population density and limited diversity, suggests that the Neanderthal network was smaller, less connected, and more geographically constrained than the network of incoming modern humans. In a world where everything is stable, this difference may not matter much. In a world that is simultaneously facing climate stress, habitat contraction, prey decline, and the arrival of a new ecological competitor, it may be the difference between adaptation and extinction. And then there is disease. The disease hypothesis is the most difficult to test archaeologically, and therefore the most uncertain. But it cannot be dismissed. When two populations that have been separated for hundreds of thousands of years come into contact, they bring with them their respective pathogen loads, the bacteria, viruses, and parasites that they have co-evolved with, developed partial immunity to, and carry without necessarily being seriously affected by them. When those pathogens cross into a population that has never encountered them, the results can be catastrophic. This is not speculation. It is documented historical fact, repeated across every instance of first contact between long-isolated human populations in the historical record. The indigenous populations of the Americas, encountering European pathogens for the first time after 15,000 years of separation, experienced mortality rates that some researchers estimate at between 50 and 90% within a century of contact. Neanderthals and modern humans had been separated for somewhere between 500,000 and 700,000 years. The potential pathogen divergence between those two lineages over that span of time represents an unknown but potentially enormous disease burden. A Neanderthal population already stressed by climate contraction and resource competition, encountering novel pathogens from a modern human population, would have had no immunological preparation for what it was facing. We cannot test this hypothesis directly from the fossil record. We cannot sequence the pathogens. But we can note that the pattern of Neanderthal population decline, patchy, geographically variable, sometimes rapid, is at least consistent with what epidemic disease does to small, isolated populations. The interbreeding complicates everything, and it should. The fact that modern humans and Neanderthals interbred successfully, producing fertile offspring in multiple distinct events across different geographic regions and different periods, means that the relationship between the two species was not purely competitive. It was not solely hostile. It was not simple in any direction. People who were genetically distinct enough to be classified as different species were nonetheless choosing, in some circumstances, to form reproductive relationships. Their children survived. Those children's descendants are alive today, carrying fragments of Neanderthal DNA in their genomes, expressing Neanderthal gene variants in their immune systems and their skin cells and their metabolic pathways. The Neanderthals did not disappear without a trace. They disappeared into us, partially, imperfectly, in ways that are still being mapped. But the disappearance was not total. It was a dissolution rather than a deletion, a merging rather than a replacement. This is the revision that makes some researchers genuinely uncomfortable, because it complicates the clean narrative of modern human triumph. If we absorbed part of what the Neanderthals were, if the genome of every non-African person alive today contains chapters written by a species we used to classify as primitive and brutish, then the story of human uniqueness becomes less a story about what we are and more a story about what we have always been assembling from the materials at hand. We are, in part, made of Neanderthals. Now consider what that means. That broad brow ridge you find in certain human faces, that slightly projecting midface, that tendency toward dense bone structure in certain populations, these are not atavisms, not throwbacks, not evidence of something primitive lurking in the modern human genome. They are inherited. They are the physical residue of a meeting, 40,000 years ago, between two kinds of intelligent, fire-using, tool-making, death-burying, ochre-applying, child-raising social mammals, who looked at each other across whatever cognitive and cultural distance separated them, and, in at least some cases, chose proximity rather than distance. What happened in those moments of proximity, we will never fully know. Whether they were violent or tender or both simultaneously, whether they were understood by both parties as significant or occurred in contexts of such gradual mixing that significance was never attached, whether the offspring of these unions were welcomed or marginalized or something more complicated. These questions cannot be answered from the genome alone. But the genome tells us they happened. The genome tells us the outcome survived. And the genome tells us that the question of what a Neanderthal was is not entirely a question about the past. It is partly a question about you. In Gorham's Cave on the southern tip of Gibraltar, where the last credible evidence of Neanderthal presence has been found, associated with a layer of hearth ash and Mousterian tools dating to somewhere between 32,000 and 28,000 years ago, depending on the analysis you accept. There is a mark on the cave floor. Not the ochre-decorated wall of a Lascaux or an Altamira, not a painting of any recognizable animal or object. It is a crosshatch, a grid of intersecting lines carved into the bedrock of the cave floor with a stone tool, requiring a minimum of 54 individual strokes to produce.
Analyzed by Francesco Dedico and colleagues and published in PLOS One in 2014, the crosshatch at Gorham's Cave is currently the strongest candidate for a deliberately produced abstract marking made by Neanderthals. Not a byproduct of tool use, not an accidental accumulation of cut marks, but a pattern made for reasons we cannot determine, by hands we cannot see. What does a crosshatch mean? We do not know. Whether it means anything in the symbolic sense we would apply to a human mark, whether it was made as decoration, as territorial marking, as tally, as something with no modern equivalent, we cannot determine. What we can say is that making it required sustained, controlled, deliberate action with no obvious practical function. It required the intention to leave a mark. Something, or someone, wanted to make a mark on the world and be gone from it. The last fire in this valley. The last fire on this particular hillside. The last warmth in the last shelter, tended by the last hands that knew how to tend it. We cannot date this fire. We cannot find its ash in the sediment with enough precision to say, this is the last one. The ending is not a single moment. It is a process, a slow removal, like the tide going out so gradually that you cannot identify the exact moment it turned. But somewhere, in the dark of a Pleistocene night, a fire burned that was not relit in the morning, and the world that had been shared, imperfectly and violently and sometimes tenderly, between two kinds of thinking, feeling, tool-making, fire-tending creatures, became a world with only one. That is not a victory. It is a loss. It is the loss of an alternative, of another way of being intelligent, of another solution to the problem of consciousness in a cold and difficult world, of another voice in the long conversation that life has been having with itself since the first cell divided in the first warm sea. We lost something when the last Neanderthal died.
We may not be able to say precisely what we lost, in the way that you cannot describe a color you have never seen. But the shape of the absence is visible in the fossil record, in the ancient DNA, in the 40,000-year-old marks on cave walls and cave floors, in the healed fractures that tell stories of survival and care, in the eagle talons strung on a cord 130,000 years ago by hands that understood that some things are beautiful. What they felt watching their last fires, what they understood of what was happening to them, whether they understood anything in the way we mean understanding. These questions have no answers. They have only the deep, clean silence of deep time, and the fossil record pressing up through it like a hand through ice. Tomorrow, in the shelter that faces south, there is more work to do. But first, one final chapter, because everything we have followed through this long day, the hunt, the weapons, the fire, the ochre, the children learning from watching hands, leads to a question that science is only beginning to know how to ask. What precisely did we lose? And what in the 1 to 4% of every non-African genome on Earth did we keep? There is a woman alive today somewhere on Earth who carries in the cells of her body a segment of Neanderthal DNA that codes for a specific variant of a keratin protein involved in hair and skin structure. She does not know this. It does not change the way she experiences her life in any conscious way. But that segment of code was written into the Neanderthal genome somewhere in the long darkness of the Pleistocene, tested against the cold and the wind and the cave lions and the competition and every other pressure that the world applied to the bodies that carried it. And it survived. It survived the extinction of the species that produced it. It survived 40,000 years of cellular replication. It survived because it was useful, because the bodies that carried it into the modern human lineage did slightly better in some specific measurable way than the bodies that did not. The Neanderthals are gone. Their genes are not. This is the central fact of the Neanderthal story as we currently understand it, and it is a fact whose implications we are only beginning to trace. The sequencing of the Neanderthal genome, a project that consumed years of work at the Max Planck Institute for Evolutionary Anthropology in Leipzig, led by Svante Pääbo and his colleagues, and that produced its first landmark results in 2010 before being progressively refined in the years that followed, opened a window into the deep past that no amount of fossil analysis alone could have provided. It answered questions that stone tools and healed fractures could only gesture at, and it raised new questions that will occupy researchers for decades to come. The percentage varies. Across different modern non-African populations, the Neanderthal contribution to the genome sits at between 1 and 4%, with some specific populations showing slightly higher values. East Asian populations tend to show somewhat higher Neanderthal ancestry than European populations, a pattern that researchers have interpreted as evidence of multiple distinct interbreeding events at different times and places rather than a single mixing episode. The initial hybridization may have occurred in the Levant as modern humans first moved out of Africa and encountered Neanderthal populations in the Middle East before the modern human expansion into Europe and Asia. But additional interbreeding events in different regions at different times appear to have added further Neanderthal genetic material to the lineages that eventually spread across Eurasia. 1 to 4% sounds small. It is not small. The human genome contains approximately 3 billion base pairs. 1% of 3 billion is 30 million. The Neanderthal contribution to any given modern non-African genome is, in raw terms, tens of millions of base pairs of sequence, a library of genetic information accumulated over hundreds of thousands of years of Neanderthal evolution embedded in the genomes of billions of living people. And it is not random sequence, passively inherited and silently carried. It is functional. Specific Neanderthal-derived variants have been identified in modern human populations, and their functional significance is being actively investigated. The findings are already extraordinary. A study published in Science in 2016 by David Reich's group at Harvard Medical School identified Neanderthal-derived variants in modern human genomes that are associated with immune function, specifically with the innate immune system, the body's first line of defense against pathogens. These variants, the researchers argued, may have provided modern humans entering Eurasia with pre-adapted immune responses to pathogens that Neanderthals had been co-evolving with for hundreds of thousands of years. The incoming modern humans meeting these pathogens for the first time may have been partially protected by the genetic legacy of the people they were replacing, protected specifically because they had interbred with them. The Neanderthals may have helped modern humans survive the Neanderthal extinction. Sit with that for a moment. Other identified Neanderthal-derived variants in modern human genomes include those associated with blood coagulation, with skin pigmentation, with metabolism of specific nutrients, with certain aspects of neurological function. A 2017 study published in Science by Michael Danneman and Janet Kelso at the Max Planck Institute found that Neanderthal-derived variants in modern humans are enriched in regions of the genome associated with skin and hair characteristics, sun sensitivity, ease of tanning, hair texture, consistent with adaptations to specific light environments and climates that Neanderthals had occupied for far longer than modern humans had. We did not come to Europe as a blank slate and write ourselves onto it from scratch. We came to Europe and found people there who had been solving the problems of Europe for hundreds of thousands of years, and we absorbed some of their solutions. Not all of them. Not enough of them to save the Neanderthals themselves, but enough to leave a mark on every non-African person alive today. Consider what this means for the standard narrative of modern human exceptionalism. The story we have told ourselves for most of the 20th century was a story of replacement. Smarter, more creative, more socially complex modern humans arriving and outcompeting their less sophisticated Neanderthal cousins, who lacked the cognitive and cultural tools to compete. This story was comforting in its clarity. It placed us firmly at the pinnacle of an evolutionary progression, the inevitable best outcome of a long process of cognitive refinement. The actual story is messier and more interesting. The actual story involves two cognitively sophisticated species, both carrying large brains and complex cultures, both using fire and making tools and burying their dead, meeting in a landscape they were both adapted to, and competing in ways that were neither purely violent nor purely cooperative. The actual story involves interbreeding, genetic exchange, possibly cultural exchange, and an outcome that was not total replacement, but partial absorption. We are the survivors, but we are survivors who carry our competitors inside us. Now let us return to the shelter. Let us go back one last time to the south-facing limestone overhang, the dying fire, the sleeping figures, the woman watching the coals. She does not know that she is the last generation of something. No individual in the middle of an extinction knows they are in the middle of an extinction, because extinction is not an event. It is a direction. It is what it looks like when the small decisions of daily survival, where to hunt, who to shelter with, whether to move north or south when the herds shift, accumulate across generations into an irreversible pattern. She does not know that 40,000 years from now, a species that carries fragments of her genome will extract ancient DNA from the bones of her descendants and read, in the sequence of nucleotides, the story of who she was and what she came from and how she ended. She does not know that the scientists who do this will argue with genuine passion and genuine rigor about what she felt and what she thought, and whether the marks on cave walls near her shelter represent the beginning of art or merely the byproduct of purposeful hands. She does not know that her kind will become the subject of documentaries and museum exhibitions and popular books and deep scientific debates that have not resolved after more than a century of argument. She knows the fire. She knows the smell of the people sleeping around her. She knows that the youngest hunter's arm will need to be checked in the morning, and that the broad-shouldered figure snores when he sleeps on his back, and that the 4-year-old will wake before anyone else reliably and will need to be kept quiet while the others sleep. She knows this valley. She knows the south-facing limestone. She knows the river and the tree line, and the place where the bank collapses into the riverbed, and the place where the prey animals water in the evening, and the place where the lion smell comes from, and the place where the birch trees grow thickest and yield the best bark for tar. She knows, in the wordless, embodied way that a lifetime of living in a specific place creates knowledge, that this is her world. Not owned, not conquered, not mastered in the way that the word suggests control, but known in every season and every weather, known through every sense simultaneously, known the way that you know the face of someone you have looked at for 30 years. This is her world, and she is of it, and it is of her. And this relationship, this specific, irreplaceable, accumulated relationship between a mind and a place, is one of the things that was lost when the last Neanderthal fire went out. Not lost from the geological record, not lost from the genetic record, but lost from the living world. That specific knowing, that specific relationship, that specific way of being intelligent in a specific place, it ended. It did not transfer. It did not merge. It simply stopped. We should grieve that a little, not as sentiment, but as honest accounting. The world was richer for containing two kinds of thinking beings, and it became poorer when it contained only one. We are accustomed to measuring the wealth of the past in tons and speeds and skull volumes and the force of bite. But the wealth of the past also included ways of knowing that left no clear deposit in the sediment, ways of being present in a landscape, ways of attending to the world that our own species, for all its extraordinary achievements, may not have fully replicated. But here is the other side of that accounting. Here is what the research of the last 20 years has given us that we did not have before. They are not gone. Not entirely. Not in the way that the ichthyosaur's gone, leaving only bones and no descendants, no living echo of its specific biological solutions. The Neanderthals left echoes. They left them in your immune system. They left them in the way your skin responds to sunlight. They left them in the specific protein structures of your hair. They left them in gene variants whose functions we are still working to understand, variants that have been present in every generation of non-African human beings since the hybridization events of 40,000 or more years ago, being selected for and against and maintained and sometimes lost, but never entirely absent. When you look at a fire, when that specific slightly unfocused quality of attention that a moving light source draws from your visual system settles over you, and the thinking slows and opens and becomes something more like feeling than reasoning, you are doing something that Neanderthals did. Around fires that burned in limestone shelters that faced south, in valleys that are now buried under 40,000 years of sediment and forest and civilization, for hundreds of thousands of years before a single modern human set foot in Europe. When a hunter today reads a landscape, reads it in the old way, with the whole body, attending to wind direction and ground softness and the quality of silence in a particular part of the forest, they are using cognitive tools whose deep history includes Neanderthal minds in Pleistocene valleys, running the same calculations, attending to the same signals, reading the same world. When a parent tends a sick child through the night, using whatever is available to reduce fever and ease pain, drawing on knowledge that has been passed down through direct instruction and direct example across more generations than can be counted, they are participating in a tradition of care whose documented history, in the fossil record, includes an old Neanderthal at Shanidar Cave who survived for years with his withered arm and his healed skull fractures and his arthritic joints because someone else made sure he ate. These are not metaphors. They are not poetic flourishes. They are the actual, material, biological continuities between what happened in that shelter 40,000 years ago and what is happening in the world tonight. The Neanderthals were not a failed experiment. They were not a rough draft of something better that came later. They were a complete and extraordinary solution to the problem of being a large-brained social mammal in a cold and dangerous world. A solution that worked, brilliantly and completely, for hundreds of thousands of years, which is longer than our own solution has yet been tested. They hunted things that would kill a modern soldier. They made tools that require skills we have to spend months learning to replicate. They maintained fires across winters that would end a modern person without shelter in hours. They cared for their injured and their elderly in conditions where carrying a non-productive member represented a real metabolic cost to the entire group. They decorated themselves and their objects with colors they chose for reasons that were not practical. They placed their dead in the ground with care. And they did all of this in a brain shaped differently from ours. Not inferior, not superior, but different. Another answer to the same questions. Another voice in the conversation. That voice is silent now. Has been silent for tens of thousands of years. But the conversation it contributed to is still going. You are having it right now, in a brain that carries in its genetic instructions a small but real and functional inheritance from the last people who sat in this valley and watched this fire. The woman at the fire is not watching us. She does not know we are here, 40,000 years downstream, trying to read her by the light she left behind. But we are here, and we are reading, and what we are reading is not primitive and not simple, and not the story we told ourselves for most of the 20th century. It is the story of someone who knew something we have forgotten. Someone who lived in a specific world with a specific depth of knowledge that took hundreds of thousands of years to accumulate and a few thousand years to lose. The fire dims. The cold presses against the entrance of the shelter. She adds one more piece of wood. Dense, dry, chosen from the store at the back. The right size, the right density, the kind that will burn slowly and hold heat through the darkest part of the night. She has done this before. She will do it again tomorrow. She does not know it is one of the last times anyone of her kind will do it in this valley, in this world, on this particular edge of an extinction that is already underway in the north. She adds the wood. The fire catches. The shelter fills one more time with light. And somewhere in the darkness of deep time, between that fire and this moment, between that woman and the people reading these words, a thread runs, thin, improbable, 40,000 years long, woven from ancient DNA and healed fractures and eagle talons, strung on a cord and cross-hatched lines on a cave floor, and the specific, irreducible fact of a consciousness attending to a fire in the dark. We did not lose them entirely. We carry them in the 1 to 4%, in the fire focus, in the deep, automatic knowledge of south-facing stone. In the part of us that, when the world goes quiet and the light goes low, still knows how to tend a flame and wait for morning. That is what Neanderthals were. That is what we kept. 4%. In the fire focus, in the deep, automatic knowledge of south-facing stone. In the part of us that, when the world goes quiet and the light goes low, still knows how to tend a flame and wait for morning. That is what Neanderthals were. That is what we kept.